encoder, we have only one track, correct? In which there are holes, or two tracks with holes. But in case of what you call as absolute encoder, I have a transparent disk which is divided into, for example, 4 tracks and 16 segments. Okay, and for each track, correct? Because this is the front view, this is side view. One side I have light source, other side I have photo transistor. Again, I have 4 tracks. That means there are 4 light sources. I say that L1, L2, L3, L4. 4 this one side. Other side I have photo transistor P1, P2, P3, P4. They are aligned. And this is my disk. This is my disk shaft. My motor is there, our engine is there. When this is rotating, disk also will rotate. When it rotates, you will see that alternate become, whenever this part is coming in front of the light source, the light will travel. One side is my light source, other side is my photo. Light will travel. But if the black color comes, what will happen? Light cannot travel. So you will see that alternate, the light will go and hit the photo transistor. That time photo transistor will generate one pulse. Will generate one pulse. Okay, so like that, there are 4 tracks. 4 tracks will generate light pulses whenever light hits on it. So this is called B0, B1, B2, B3. This is called a binary pattern. Correct? When the disk rotates, it generates a binary pattern. Okay, what binary pattern is going to generate is, I will show it here. Okay, so my disk contains, because you know that there are 4 tracks divided into 16 segments. So this is my B0, B1, B2, B3. And so since I divided in 16 states, this is first state 0. This is 1, 2, 3, 4. Like that I can go like the last one is called 15. Correct? So now, if this is there, what I will get? I will get light will pass 1, 1, 1, 1. I get 4 pulses. If next one, if this segment comes under the 4 lights, what will get? This will become 0. Correct? This will become 0. Remaining will get light. When it comes this part under this light source and this one, what will get? You will get 1, 1, 0, 0. Okay, when this comes, this segment comes, you can see that it will become 1, 0, 1, 1. Like this, it is going to come. Okay, so this pulse, you can see that if I count, because only one thing what you have to do is you have to invert this. Okay, so now this state represents 0 to 50. Correct? So now my 3C, when the disk rotates one rotation, how many degrees is rotating? 360. And it is divided into 16 segments. So the resolution, angle resolution of this absolute encoder is 360 divided by 16. Correct? We can know that this is going to be 32, 40. Correct? So, 2, sorry, 2, 32, remaining 4, again 2, 8. Okay, if that means it can measure angle resolution equal to 22 degree, 22.4 degrees. This is how the angle can be measured. Okay, the main advantage of this is if power goes and comes. For example, my disk is generating this pattern. Correct? They call binary pattern. Now, when disk is rotated by 20, for example, I get 4 means 22.4 into 4. So many degrees this shaft has rotated. Now power went off. It came back. It comes means still this will generate this pulses. The encoder will generate pulses. That means I am going to count the number directly. That's why it is called as absolute encoder. It is called as absolute angle encoder. Okay. This is how the absolute angle. Any doubt in this? If you want, because clarification. Because if you don't understand, please ask, because I'm trying to explain. So the pattern generator will be if it is divided into four tracks and 16 segments, correct? So the angle resolution equal to 360 divided by 60 is going to be 22.4 degree. That means minimum angle you can measure is 22. If I want to measure, for example, still higher, I want to measure 11.2, correct? So what I do is I will add one more layer and divide into, again further divide into this one, 32 segments instead of 32 segments, 5 tracks, correct? So this is the outermost track, correct? T0, this is T1, T2, this is T3, and this is T4. Now I have 5 tracks, I divide into 32 segments. So in that case, what will happen? The resolution R equal to angle resolution AR equal to 360 divided by 32 is going to be 11.2 degrees. Correct? So if I want to measure more accurate angle, what I have to do, I have tracks and divide into more. So next I will show 64. Please know that number of segments will be always 2 power 0, 2 power 1, like that only, correct? Number of this one. So if I have 6 tracks, divide into 2 power 6, that is going to be 64 segments. Like that, if I have 8 tracks, 2 power 8 is going to be 256 segments. Okay. Now what is my angle resolution? R equal to AR equal to 360 divided by n into, correct, n into, I say 2 power n. 2 power n is nothing but where n equal number of segments. So 360 divided by 2 power 8 is nothing but 360 divided by 256. Correct? Is going to be 1.2 something. Correct? I can measure 1.2 degree. If I, that means if I want to measure higher, I make 9 tracks and 512 segments. So in that case, 360 divided by, that is 9 tracks and 512 segments. That is, in that case, what will happen? Will be lesser than 0, 3600. We can say that 3600 by 500 is going to be 6, correct? I can say, in fact, no, 0.7. 0.7 into 0.7, 0.7 something degree you can measure. This how it works. What is the advantage? This one is, even if power goes and comes, the binary data is automatically created because this one. So this is the advantage compared to incremental. The how many degrees moved, it can be again measured when power comes. The counter will not reset. The sensor directly produce the how many degrees shaft is rotated as a binary number. That is the advantage. What is disadvantage? If I have 9 tracks, I need 9 light sources, 9 phototransistor. So the overall cost of the sensor increases. This is how the absolute angle encoder works. So you will see this in case of this one. Wherever you want to measure, CNC machine, all these things. Because CNC machine can rotate angle, correct? You want to cutting tools, drilling, something you want to measure, the motor angle, you want to measure, you use absolute encoder. If you want to measure the speed, you won't use absolute encoder. See, absolute encoder generally used for angle measurement, no doubt, correct? Accurately, and it is expensive. Incremental encoders are used for measuring speed because only one phototransistor or 2 phototransistor with a disk measuring speed, rotation. Make it with one hole sufficient, then I can measure with one hole in a disk, and the phototransistor, this one, this can be used for measuring speed. Wherever you want to measure speed, you will use incremental encoder, wherever you want to. But please note that incremental encoder can be measured for angle, this one also, angle also, by making more number of holes in the periphery, correct? Here, more number of holes you can make, you can use it for angle measurement, but many times it is used for measuring speed. Okay. Okay. Now, before going out, I want to say that in engine, for example, you want to measure P theta diagram, correct? You will use what you call optical encoder, correct? Shaft angle encoder or crank angle encoder. We call as crank angle encoder, correct? Where they are using incremental encoder only. You can see that this is I got a picture. This is the measurement. Generally, you can measure 0.1 degree because, for example, AVL, correct? AVL is one of the company which makes angle encoder because I use it. It cost around 1,80,000 or 20 years before. Now it has reduced, but previous is so expensive, which can measure 0.1 degree crank angle because it has 360 degree. You can see that this slot, there are 3,600 slots. One side you have light source, the light source inside, and then it produces three signal, 0.1 degree accuracy angle signal, correct? And it also one trigger signal and one reference signal. It produces three signal so that you know that where is the TDC. This will be the signal will be aligned with the TDC signal, and this gives the angle. How many degrees the shaft as a crank shaft is rotated with point. So here they are using incremental encoder, correct, for measuring theta and controlling engine firing angle, when to give spark, when to give the fuel injection, diesel engine, all these things they use. This is incremental encoder. Okay, optical encoder details are commonly used for provide position feedback, correct, and consist of glass or plastic disc rotating between light source and a photo transistor, and a disc is encoded because in case of this is absolute encoder, correct? Absolute encoder, disc is encoded with black and light pattern, which is a binary pattern. So the sensor produces a binary signal that can be directly counted, and you can say what is the current angle. Even power goes and come back, the absolute encoder gives what is the current angle rotation of the shaft because it directly produces binary value, not incremental value. Okay, so same thing can be used for linear measurement also. Linear means, for example, this is the graded score. You can see that this is the graded, correct? Graded scale. That means alternate black and white is there. This is, for example, a moving object. This is not rotating object, a moving object, linear movement. The object is moving object is connected to the grading scale. The whole thing is my sensor. Okay, this is called linear encoder, and you can see the one light source is there, and I have the photo transistor here, this side, light sensing. Okay, then when this is moving, and I can measure how much distance is moving, and so you can see the photo trans this one, and the two pulses. This is a quadrature sensor, which direction is going, correct? Left to right or right to left, you can sense it. So this is for measurement, linear measurement. Please note that the angle encoder need not be only rotational, and linear also you can accurately measure using photo transistor. Okay, we also, so with this I will complete. We saw that six type of sensor, correct? Let me go back. I want to close sensors today. Next class I want to talk different, because sensors are very important mechatronics. That's why I took more than 5 to 6 classes or even 7 classes, correct? How it basics in also working. Classification, this is very important chapter. Every chapter important, but anything you need to understand. That's why classification. Yeah, I started with clarification, change in resistance, change in capacitance, change in inductance, piezoelectric sensors, already we talked, thermoelectric effect and photoelectric. Thermoelectric, did we talk about it? Yes?
Yes, sir.
No, but I think just 1 minute I want to talk about that. I think one slide I have. If you don't mind, I will complete that, even if you have not seen. Yeah. Thermoelectric, I know that just 2 minutes I will take. Thermoelectric effect is nothing but thermocouple is an example. What is a thermocouple? Two dissimilar metal wires fused together to form a junction. Correct? Form a junction is called as thermocouple, which produces an EMF, that is electromotive force. Unit is volts, generally millivolts. When junction is exposed to thermal energy, that is measured temperature source. For example, I take a wire called as A, one material, other one I call as a B type material. There are two materials. We'll see next slide what it is. Two different material to be taken, not same material, two wires. One is called A wire. Now I form two junction. What I did, B, this is a B material and a small piece, and this is another piece, and a material longer one. I joined to this by melting, not just twisting. Twist is this one, heat it, melt it, form a junction. This I call junction 1, and this I call as junction 2. Correct? For example, this is Cu. Correct? Copper. This is a copper wire, and B material is not even constant. Correct? Constant material is there. Now, two pieces are constant material. One piece is, it has two ends. One end is connected or fused with the copper. Similarly, second constant is also fused. So I form two junction. Now this is called as thermocouple. Okay. Now one junction, I say T1 junction, I keep it at 0 degree centigrade, which is called a reference sensor. Correct? Reference junction. Correct? I maintain at 0 degree. No, that is known temperature. For example, ice. Ice know that if it is ice is 0 degree. So the junction is buried inside the ice. The other junction is called as the measuring junction. This is called as measuring junction. Measuring junction is subject to T1 is 0 degree. That is reference. T2 is subject to I want to measure temperature, some hot material. So the junction is going and touching the junction. What will happen? From that material, heat energy Q, so many joules will be, millijoules, microjoules will be transmitted, correct? Through the conduction to the junction. As this one, the temperature of this junction increases. Initially, it was T2 was room temperature. For example, at this temperature, generally it comes 0, but right now, because I am maintaining the ice, so this being 0 degree, this open means I said 25 degree in my room, correct? It is 20. Now, as I inject more heat from this one, because the junction is touching hot surface, so the temperature increases, say 30, 40, like that increases. So, for example, the hotness is 100 degree. Now, the T2 reaches 100 degree. Correct? Automatically, as the temperature increasing, then it will produce a EMF. Correct? So, the thermocouple generates a EMF. The EMF produced is proportional to, that's what is shown here. EMF produced at this junction. One wire is called a plus, other is called, because voltage means always plus minus. So EMF is proportional to alpha into T1 minus T2. I said T1 equal to 0 degree. I'm maintaining at 0 degree with ice. Correct? Other one is the measuring junction. T2 is increasing whatever temperature. That means T1 minus T2 multiplied alpha, where alpha is called as Seebeck coefficient. That depends upon type of the thermocouple. Okay? Correct? For each thermocouple, there are B type, E type, J type, K type, N type, R type, S type, T type. These are the industrial grade that use two different combinations. One is called platinum, rhodium. Other is platinum is platinum plus 30% rhodium, one wire. Other one is platinum plus 6% rhodium. It can be used to measure the temperature in the wrist. Did we talk about this? No?
We discussed about this, sir.
Yes, sir. This table was discussed, sir.
Yeah, we discussed. I think we discussed all these things. Okay, fine. No issue. So thermocouple, that means sensors are over. Tomorrow we'll talk about what we call signal conditioners, because sensors are producing millivolts, microvolts that should be amplified. So we talk about amplifiers in tomorrow class. Okay. Thank you. See you tomorrow. Give your attendance before leaving. Sorry for taking little time. I know other professor will be waiting. Sorry.
Thanks a lot, sir. Thank you.
Because in between the net was not working, it took little time. Okay. See you tomorrow 5 o'clock.
Thank you, sir.
Okay.
Thank you, sir.
Yeah, thank you, sir.
Bye.
Yeah. Bye.
Thank you, sir.
Yeah, thank you.